Next level. Next level.
So guys, here as you can see that the surface cut is a little uneven. So guys, you can see that it is pretty stuck good. Yeah, now it's time to install it finally. There are 4 wires, which means that this is a DC clutch motor. This is the clutch, and the 2 thin wires are responsible for operating the clutch, and the remaining 2 thicker wires are for operating the DC motor. I have used some cushioning to reduce the vibration, as well as I have added screws of equal length to further minimize the vibration, plus the zip ties to hold this like impeller piece steady. Well guys, here as you can see that it is super cloudy and the sun is barely available, but still I am going to use the solar panel wires that I have here. Hi guys, this what you see is a 3 volts toy DC motor, and here in this video I'm going to perform some flying thrust tests to figure out if it can work as a motor for the drone. So guys, here as you can see that I've connected one wire to the body of the DC motor, which will get input through this iron saw, and here I have this clip. Now one terminal is left, this one. Well guys, here as you can see that I'm using a transparent tape to prevent the open wire joint to get in contact with the metallic saw. First of all, let's check if we can fly this much weight with the power supply up to 14 volts. Turning it on, yeah, 5.16. Now let's increase the voltage. Increase to 5.23, 5.40, 11. Wow. I think the weight for it to pick up was too much. Seems like the motor got damaged. It is really hot. The brushes got damaged. Although this seems fine, but the armature that they have used is very small. No wonder it couldn't generate a good thrust. Too small armature, half the size of the magnet. You see, the magnet is big but the armature is very small. We can develop the power by increasing the size of the armature, so let's change it. Well guys, I have another DC motor. Let's open it up and see its armature. This one looks better. You see, this one is a little bigger. Still not very big, but yes, a little bigger than this one. Yeah, that's done. Let's test it. Well guys, this time I've done a change. I have set this power supply at 15.5 volts DC to see if it is possible for it to achieve the lift. Okay, turning on the switch. Okay, go. Whoa. Wow, this time it was much better. Now the propellers broke. Ready? Whoa! Now guys, here as you can see that I have done a change. I have changed the motor. This one, as you can see, is a little bigger in size than this one, and the hope is that it is going to provide a little higher torque. Although it is small, but it is very powerful, and it is from a vacuum cleaner motor car vacuum cleaner motor 12 volts. Here as you can see that I have soldered only one wire as before, and I have soldered the other terminal to the body of this DC motor, which is connected to this piece and then to this iron saw. Now guys, here I'm connecting one wire, okay, and all I have to do is touch the other wire to this saw and it should start working. Okay, so let's start it. Supply is turned on and as you can see that it is flashing 8.72 volts, a little less than 9 volts. Let's touch it and see the direction. Yeah, it is running very fast. Whoa! Well, now guys, I have placed it so tightly that even if the table flies, this won't come out. You see that it is flying only at 8.5 volts. Well, now as you can see that I have reduced the voltage to 6.20 volts. Let's test it now. Okay. Whoa. Starting once again. Whoa. Whoa, whoa, whoa. Fish. Well, the blade broke. Well guys, one propeller destroyed. I have this last piece remaining, but this time I'm going to place a lock over here so that when it comes flying like this, it finds something to lock. Yeah, I think this should do. So guys, I have held the board tight with a C-clamp and the table, so it is fully held in one place. Now all I have to do is just turn the knob and switch on the supply. So let's do that fast. Increasing the volts. 3.8, 4, 4.09. Whoa! Well, I was so close. Guys, it's already at 4.2 volts. Let's turn it on. Increasing. 4.16, 4.30. Very close. Wow. A little more. You see? 4.71, it is taking flight. You see? It is flying slowly and slowly. Cool. I will give you a close view. Running so fast. Whoa, 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 whoa. Wow, why is it coming upwards? Whoa, 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 no, 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 no. No, 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 stay below. Yeah. What do you, yeah, it is coming again. Oh, no, 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 no. Oh, let's turn it off. Yeah, it is getting really dangerous. Well guys, it is already set at the exact needed volts. All I have to do is turn it on for once again performance, because the upper part was a little cut down. Yeah, and now it's in the screen. Okay. You see how stable it is and how beautifully it is rising up. Nice, right? Cool. Yeah, it's like it is taking baby steps to come upwards. Oh! No, 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 no. As you can see that the performance of the vacuum cleaner motors is just amazing. At present, I'm operating it at 1/3 of its power, only 1/3. No additional circuit, only 4 volts, 4.75 volts is what I'm giving it here. And it is flying really nice, with really good thrust. You see 4.75 volts, and here it is. Cool, right? Nice. Whoa, 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 whoa. Let's turn it off. Yeah. And one more thing, guys, since I'm operating it at only 1/3 of its power, the motor is not very hot. It's like its usual performance is 3 times more. So you see that how good these vacuum cleaner motors are actually for the drone. Now I will show you its winding, how thick the copper winding it is. You can see the thickness of the winding over here. It is a 12 volts high current, high RPM motor. Much more powerful than these simple toy motors.